The stars you see tonight, they might not be natural. That's the search for cosmic megastructures. It's looking for the ultimate fingerprints of intelligence. Out there in the dark, we're going to explore 25 theoretical constructs, so vast they bend the laws of physics. They redefine what a civilization can become. And by the end, you'll see the night sky differently. You'll see it as a blueprint for impossible engineering. So what if a distant sun dims in a strange way? What if that's not a cosmic accident, but a shadow from a project spanning millions of years? And could our entire galaxy already be threaded with highways of light? Highways we can't yet perceive. The universe might be less a wilderness and more a workshop. So then, what single idea from this future feels most within our reach? The Dyson sphere is the first of these cosmic fingerprints, but it's not a single rigid shell around a star. That's an engineering nightmare. The more plausible version is a Dyson swarm. Think of it as an energy grid, millions, maybe billions of individual solar collectors, all orbiting their sun in a synchronized dance. Their goal is to capture every photon of light the star produces. For a civilization that's outgrown planets, this is the next step, turning their solar system into a single machine for power generation. Freeman Dyson had a way to find them. A star wrapped in a swarm wouldn't disappear. It would change. The visible light gets captured and used, but all that energy eventually gets radiated away as waste heat. So you'd look for a star that's strangely dim in visible light, but glows intensely in the infrared. A cosmic engine radiating the warmth of an entire civilization. The scale is hard to grasp, coordinating the orbits of countless collectors to avoid collisions, maintaining them across millennia, harvesting and transmitting that energy. The individual pieces could outnumber every satellite and probe humanity has ever launched by a factor of 1 billion. It's a declaration of ambition, a signature written across the thermal spectrum of a sun. And if that's a civilization harnessing its own star, what would one look like that has learned to move stars? You'd be standing on a flat plane of solid matter, and it would just curve away from you in every direction, fading into the haze. That's the Alderson disk. It's a plate of engineered material so huge that its inner edge orbits a star, like a ring around a finger, with the sun held right in the middle of the hole. The scale isn't planetary, it's systemic. You're taking a solar system's worth of mass, flattening it to create one continuous landscape. The surface area is millions of times greater than all the planets combined. You could walk forever and never find an edge, just more of that same engineered plane. And gravity here, it doesn't pull toward a planetary core. It pulls straight down toward the midline of the disk's thickness. Stand on the surface and look straight up. You wouldn't see empty space. You'd see the underside of the disk's other side, a ceiling of land and atmosphere thousands of miles above, lit by the same central sun. It's a world without a horizon, a habitat built on a flat infinity. The engineering, of course, is beyond anything we can conceive. The tensile strength to keep the disk from tearing itself apart under its own gravity. That requires materials that don't exist in nature. And stabilizing the star perfectly at the center of the hole, so it doesn't drift and burn through the rim. That's a problem of orbital mechanics on a godlike scale. It's less a construction project and more an act of cosmic architecture, reshaping a star system from a collection of orbiting bodies into one unified, unimaginably vast dwelling place. It's the ultimate demand for living space, a solution so extreme it makes planets seem quaint. But if a disk redefines a solar system, what kind of structure would it take to redefine motion itself? The ringworld is another idea. A ribbon, really, a thin band circling a sun at just the right distance. The star is at the center, like the hub of a wheel. And the inside of the ring is where you'd live. You spin it, and the spin creates gravity, pulling everything to that inner surface. You could look up and see the rest of the ring curving overhead, a strip of land and sky going up and away until it disappears. The sun would just hang there, fixed in the middle of everything. The living space is, it's hard to even say, millions of times the area of Earth. A single mountain range could wrap around our entire planet. An ocean so big you could sail for 1,000,000 years and never find a shore. It's the ultimate act of turning empty space into a place to live, but the design has a flaw. A deep one. The ring isn't stable. It's perfectly balanced, but only in theory. Any little nudge, any small shift, and the whole thing starts to drift. It would begin to slide toward the sun. To stop that, you'd need thrusters, huge ones on the outside, firing forever just to keep it centered. Or maybe a second ring, a counterweight of rock and mass, orbiting the other way to balance it. It's a monument that needs constant correction. A perfect world that has to fight the universe's tendency to fall apart. And if you can build a ring to live in a star's light, it makes you wonder. What would you build if you wanted to control the star itself? That gentle drift of a star across the galaxy, that's navigation on the biggest scale. The Shkadov thruster is the simplest idea for that kind of engine. You picture a huge curved mirror built from the material of whole planets. It doesn't enclose the star, not like a Dyson sphere. It sits off to one side like a vast parabolic sail. Its only job is to reflect some of the star's own light back at it. The physics is simple. Light carries momentum. A photon from the star hits the mirror and bounces back, and that gives a tiny push. The mirror pushes the star, and the star pulls the mirror with gravity. Locked together like that, the whole system moves, the star, the mirror, every planet in orbit. It's a slow acceleration, a patient one. A civilization using this isn't taking a quick trip. They're setting a course for a destination that might take 10 million years to reach. They're planting an oak tree, and their descendants 1,000 generations later will sit under it. Why do it? To escape a coming danger, maybe. A nearby star set to explode as a supernova, its radiation a countdown clock in the sky. Or to start a migration, steering their home system toward the richer stellar nurseries in the galactic core. It changes a civilization from passengers on a random, drifting star into pilots. Their home isn't just a place they live, it's a vessel they command. They think in epochs. Their ambition is measured in light years per eon. It's the ultimate long view. But a journey like that needs unimaginable power, sustained for geological time, which leads to a more basic question. What if you could harvest power not from one star, but from the most violent engine in the cosmos? A star's light isn't just energy, it's information. Structured energy you can process and think with. That leads to a structure that's not a home or an engine, but a mind. A Matrioshka brain. You picture a series of shells nested like layers around a star. Each layer is a Dyson swarm, a computational substrate. The innermost layer is closest to the sun, operating at searing temperatures. It captures the raw stellar fury and uses it for computation, but that creates waste heat radiating outward. The next layer captures that heat, uses its lower temperature energy for its own processing. And so it goes, layer after layer, out into the freezing dark. The outermost shells run on the faintest whisper of residual warmth. It's the ultimate recycling engine, turning every last joule of a star's output into thought. The purpose is almost beyond understanding. It isn't for living beings as we know them. A civilization that builds this has likely transcended biology. Its citizens, their minds, their culture, might exist as uploaded patterns within this stellar-scale computer. It could be running simulations of entire universes, exploring every possible outcome of history, solving mathematical problems so profound they reshape reality. The star becomes a processor. its lifetime, billions of years, becomes the runtime for a single, continuous train of thought. This is where intelligence, having mastered matter and energy, turns inward to master consciousness and information. The ultimate goal is no longer expansion, but comprehension. So if a civilization can build a brain from a star, you wonder, what might it build when it looks at the empty dark between them? A star isn't just a power source. It's a vault, a bank. It holds all the raw stuff a solar system is made of. So what if you didn't just take the energy? What if you opened the vault? That's star lifting, mining the star itself for fuel. A star is this huge ball of hydrogen and helium churning. Fusion at the core makes it shine. Star lifting uses magnetic fields or focused energy beams to pull streams of plasma off the surface. You're not destroying it, you're harvesting, siphoning the fuel. That material could build more Dyson swarms or habitats or power other projects. It's the ultimate extraction. The star becomes a power plant and a quarry, and there's a side effect. If you remove mass carefully, you can extend the star's life. A lighter star burns slower. So this civilization isn't just consuming its sun, it's practicing stellar medicine, keeping the star in a stable, productive middle age for billions of extra years. They become gardeners, pruning their own sun to sustain everything. The amount of material is hard to grasp. The hydrogen in one average star could make millions of Earth-sized worlds, or trillions of orbital habitats. Over geologic time, you could reduce a star deliberately, patiently, dim its brilliant fury, shape it into a cooler, longer-lasting engine. Surrounded by a cloud of constructed matter, the star becomes a project. Its whole life cycle, from birth to old age, isn't natural anymore, it's managed. That changes the relationship completely. The star isn't a distant, untouchable god. It's an asset, a reservoir of cosmic capital to invest. And if you can manage one star like that, it leads to the next question. What could you build if you decided to manage two? But all that knowledge, all that power, it doesn't mean much if you're alone with it. A mind that big, even a Matrioshka brain would be isolated. So the next step is connection. A civilization that controls its star might look out and see other stars not just as lights, but as points in a network. They could build an internet for the galaxy, not with cables but with stars. A star is the ultimate signal booster. Its energy output is immense. Now picture placing lasers around that star, maybe in the same orbits as a Dyson swarm. You wouldn't just shine the star's light out, you'd modulate it, encode data into that energy, shape it into a tight beam aimed exactly at another star in the network. That receiving star would have its own array to catch the signal, amplify it, send it on. One sun's light becomes the carrier wave for a message to another. The advantage is range. A laser from a planet spreads out and fades over light years. But a beam powered by a whole star, it could stay coherent, a needle-thin line of information crossing the dark with very little loss. Over centuries, you could weave a web of these links, a real-time information grid across the spiral arms. A civilization on one side of the galaxy could share an idea, a discovery, with a culture 50,000 light-years away. They wouldn't be broadcasting radio and hoping. They'd be making a call on a secured line. The coordination it takes is almost poetic. It means aligning projects that last longer than human history. Building a transmitter around one star, knowing the receiver around a distant star won't be finished for millennia. It's an act of faith across generations. But the result changes the galaxy. No star system is an island anymore. Isolation becomes a choice, not a condition. Knowledge doesn't get lost or rediscovered. It flows, it accumulates on a scale we can't really grasp. It creates a shared consciousness for an entire galaxy. And once you can send information instantly across that distance, a new thought appears. What if you didn't just send information? What if you sent yourself? A network of light is still slow. Even at light speed, a message across the galaxy takes tens of thousands of years. For a civilization thinking on that scale, that delay is manageable. But travel is different. Sending information is one thing. Sending matter or people is a problem of a completely different scale. Rockets are inefficient. They're slow and costly. To become an interstellar species, you'd need a highway, something permanent, something that makes leaving your world as simple as stepping onto a train. That's the space fountain. It's not a tower built from the ground up like a skyscraper. That would collapse under its own weight. The space fountain is held up not by solid materials but by motion. Imagine a vertical tube from the surface of a planet high into space. Inside that tube, a constant stream of tiny projectiles, fired upward from the base at incredible speed. They race through the tube, and at the top, a magnetic system catches them, reverses their direction, sends them hurtling back down. It creates a continuous high-speed loop. A river of mass flowing up and down, and that's the magic. That flowing river, through magnetic levitation, pushes outward on the walls of the tube. It's this kinetic pressure, this constant rush, that holds the entire structure rigid against gravity. The tower isn't standing on the ground, it's being pumped up from within, so you don't need a miracle material, you need precise control, immense energy. Flawless magnetic systems, the payoff is a bridge. A platform at the top, in geostationary orbit, becomes a loading dock. Payloads are lifted not on rockets, but on magnetic sleds riding inside the fountain itself. A silent, smooth ascent. From there, with the hardest part done, ships can launch with a fraction of the fuel. It's a fundamental shift from explosive, one-time use chemical reactions to an architecture of sustained motion. The fountain is alive. It only stands because it never stops moving. It turns the problem of mass into a solution of momentum. And if you can build one tower that stands on a river of projectiles, it makes you wonder. What else could you build with pure kinetic energy? Where does that principle lead, applied not to a tower, but to an entire habitat? A space fountain is one structure. But to open up a planet, you need a network, a constant flow. That's the orbital ring. It's a slender, rigid bracelet of metal and composite, circling the whole world just above the atmosphere. It doesn't orbit in the normal way, balancing gravity and motion. This ring spins faster than orbital velocity. It's moving so fast that its own outward force, the centrifugal push, is stronger than the planet's pull. It wants to fly away, but it's held in place, pinned by a forest of tethers down to the surface, and these aren't cables in tension holding the ring up. They're in compression like bridge pillars, pushing down to keep that hyper-energetic ring from escaping. The ring is a captive, a humming loop of kinetic energy in a precise, artificial balance. And those tethers, they become the ultimate elevators. A carriage rides up one, not fighting gravity with rockets, just climbing a fixed, stable line. It turns a rocket launch into a smooth, electric ascent. You step in at the ground station, and minutes later you step out onto the ring, in space, but the ring is more than a terminal. It's a highway because that ring is spinning at incredible speed. If you release a spacecraft from its outer edge, you're not starting from zero. You're already moving at a significant fraction of orbital velocity. Launching to the moon or to other planets becomes far cheaper, like jumping off a moving car instead of sprinting from a standstill. For a civilization building a Dyson swarm, these rings become indispensable infrastructure. Picture your home planet wrapped in a glittering band of ports, factories, shipyards. Raw materials mined from asteroids are delivered here for processing. Finished components for solar collectors are assembled and launched outward to their places in the swarm. Passenger liners arrive and depart on schedule. The planet's gravity well, once a deep pit that consumed energy to escape, becomes a managed gateway. The surface and orbit are fused into one continuous economic zone. The ring is the planetary dock, the rail yard, the customs house, all in one silent, spinning loop. It's a shift in thinking. You're no longer launching from a planet. You're operating through a planetary interface, and if you can build such a precise, energetic ring around a planet, it raises another question. What if you built one not for traffic, but for transformation? What if you built a ring designed not to launch ships, but to capture and redirect the essence of a star? A highway of light needs somewhere to go, somewhere that justifies the trip. The most ambitious travelers, they might not be aiming for a new star. They might be looking for a new kind of home. You have the classic idea, an asteroid hollowed out, spun up for gravity, terraformed inside. A self-contained world, but you could think bigger, much bigger, a bishop ring. It's a cousin to the ring world, but scaled down to a human scale. Imagine a giant metal band. Maybe 1,000 miles wide, rotating in space. The inside surface is your landscape. Rivers, forests, cities, all under a huge, transparent roof that holds in the air. The scale is still enormous. It could hold billions, but you could build it with materials from one solar system. It doesn't need a star at the center. It's independent, a crafted bubble of life just floating out there. You could build thousands of them, archipelagos in the dark. It's the final step for a civilization that's left its planet behind. Not to take over other worlds, but to make new ones from nothing. Each ring is a choice, a specific climate, a specific culture, a specific purpose. Some for art, some for pure research, some just to preserve wilderness. They're worlds made on purpose. And if you can build a ring that holds a biosphere, you start to think about the ultimate kind of preservation. What do you build when you want to save not just one culture, but every possible culture from the end of everything? The most finished world might not even circle a star. It could just hang there still, right at the edge of a black hole. That's the Birch planet, an idea from a physicist, Paul Birch. It's a solid shell, built at one exact distance from the singularity. Not in orbit, but held in balance. That distance is the photon sphere, where gravity gets so strong that light could, in theory, just go in circles. To put a structure there, you'd have to spin it almost at light speed just to keep it from falling in. The engineering, it's a contradiction. You'd need a material with impossible strength to keep from being torn apart by tidal forces that would pull a planet apart like soft candy. And you'd have to build it from the outside, moving inward. A project where the builders themselves would fight extreme time dilation. But if you could do it, the view. It would be a physics lesson painted across the sky. The black hole would take up everything. A dark sphere circled by the bent and twisted light of the whole universe wrapped around it. The benefit comes in two parts. First, energy. The black hole's accretion disk, that superheated whirlpool of falling matter, would be a power source bigger than any star. Or for a black hole that's older and quiet, you could try to collect the faint Hawking radiation it gives off. The second thing is deeper, it's time. At that boundary, gravity bends time itself. For anyone living on the shell, time would move incredibly slow compared to everywhere else. 1 year for them might be 1,000,000 years outside. It stops being a planet, it becomes a time capsule. A civilization could go there and retreat, watch from the edge as cosmic ages flash by in the outside universe. They'd see stars die, galaxies drift apart, light fading over trillions of years, all within just a few of their own generations. It's the final observatory. Not for space, but for deep time. A fortress built not against an enemy, but against the end of everything. But a place like that, balanced on the edge of nothing, is really a monument to surviving through being alone. It makes you think, what would a civilization build if it went the other way, not hiding at the edge, but weaving itself into the galaxy's whole fabric? Connecting it all, That desire for connection isn't shared by everyone. For some, the goal is the opposite, to vanish completely. If you can engineer stars, you can also hide them. A cloaking shell is the ultimate form of privacy. It starts with a simple question. What if you didn't want to be found? You wouldn't just dim your lights. You'd have to hide your sun. The simplest way is a perfect absorber, a shell or a swarm built to catch every bit of light and radiation from your star and your world. Then you release that energy again, but only as a faint, even glow of infrared heat. From far away, your whole solar system would look like a slightly warm dust cloud. Just a blur in the data, a forgettable smudge. There are more complex ideas too, using gravity to bend the light from stars behind you so your system seems untouched. Or building planetary-scale materials to guide light around you, like water around a stone. A perfect cloak in space. The reason behind it is deep. It might come from fear. A lesson learned about a dangerous galaxy, pushing a species to become ghosts for safety. Or it could come from looking inward. A civilization so focused on its own alien culture, its own pursuits, that the noise from outside is just a distraction to be erased. This idea changes the great silence, the fact we see no one. It gives it a different feeling. The universe might not be empty. It could be full, but with everyone in hiding. Watching, listening from behind perfect dark mirrors, and if some choose to fade into the background, it makes you wonder what others might build to do the opposite. To make a mark so bright it's seen from another galaxy. Privacy is a choice, and if a civilization chooses the opposite, if its goal is to be seen from the farthest void, then you get something like an Astroengineering beacon. It's not about function, it's not about survival, it's a shout into the cosmic dark built on a scale that guarantees it's heard. Think of a star, but one that winks. Not with the natural flicker of a variable star, but with a precise, rhythmic dimming. You could do that with a series of vast, orbiting shades, artificial moons crossing the star's face in a complex, repeating sequence. And the pattern wouldn't be random, it would be a message, a sequence of prime numbers maybe, or a mathematical constant. Something that screams intelligence to anyone who sees its light. It's a lighthouse, but one that uses a sun as its bulb, or consider a laser, a stellar-scale optical array powered by a Dyson swarm. It wouldn't just shine, it would pulse. A tight beam of coherent light aimed at promising star systems, or just broadcast in all directions, carrying not just a simple pattern, but maybe an entire library. The energy cost is staggering. You're diverting the output of a civilization from building and growing and pouring it into a single, focused act of saying we are here. It's a monument to the idea that connection, the sheer act of being known, is worth more than any material resource. The philosophy behind it is profound. It could be an invitation, a hopeful hand extended across the light years, or it could be a warning, a boundary marker telling others to keep away. It might even be a memorial. A way for a fading culture to etch its existence into the fabric of the cosmos before it passes, to ensure it is remembered. The beacon is pure signal, stripped of all noise. It transforms a star from a natural object into a cultural artifact. Its light becomes a carrier wave for meaning, and if a civilization is willing to spend such vast effort to communicate its existence, it suggests a deep, underlying drive. Not just to be, but to be understood, to participate in a conversation that spans the galaxy. But that monumental effort to speak, that's only one side of a greater ambition. What would they build if their goal shifted from sending a message to gathering every message ever sent? A beacon sends a message, but then you think, what if the goal wasn't to send one message, but to receive every message? To keep them safe forever. That's the idea of a galactic library. It's not for active research, not for the builders themselves. It's an archive built for the deep future. You'd put it in the most stable place you could find, maybe the calm center of a globular cluster, or a gentle orbit around a white dwarf star, something that lasts. The location is about one thing: endurance across cosmic time, and the library itself would be a vault. Its records could be physical, diamond plates or neutronium with inscriptions at the atomic scale, or crystals storing light in complex patterns, or it could be a vast, dormant data core, powered by the faintest trickle of energy just waiting in the dark. And its contents would be everything: the total knowledge of a civilization, not just their science and history, but their art, their philosophies, the nuances of their languages, the echoes of everyday life. And it's encoded not for easy use, but for ultimate durability, for universal decryption, using mathematics and physics as the key. This whole project comes from a kind of profound ambition. A melancholy one. The builders know their own culture, their own star will fade, so they build a monument not to their power, but to their existence. It's a gift left for whoever comes after, a whisper into the abyss of time saying we were here, and this is what we learned and what we felt. It turns knowledge from a tool into a legacy. The library is a promise that even after their last sun goes out, something of their story remains, orbiting in the eternal night. It's an act of hope against the universe's indifference. But then, a repository that vast, meant to preserve the past, it makes you think of the opposite. What if you could build something not to preserve reality, but to simulate every possible version of it? A library holds one reality, but a civilization might want to see all of them, every possible one. That's where you end up if you master computation, the reality simulation engine. It's not built for living, not for travel, it's for creation, pure creation. It's powered by star energy, maybe a Matrioshka brain, and its only job is to run simulations. Not models, not games, full universes, with their own physics, their own history, their own consciousness that emerges inside. The scale of computation is almost spiritual. To simulate every particle in a universe, you'd need a computer bigger than that universe. So the trick is you only simulate what's observed. You render the detail only where a simulated mind is looking. The rest stays in a haze, a probability. It's a universe of attention running on logic gates as big as planets. For a civilization past biology, this is the final canvas. It could be science. Run a universe where gravity is slightly different and watch the galaxies. It could be art. Make a cosmos where light acts like sound and watch civilizations write symphonies from starlight. Or it could be entertainment, or a way to preserve memories, to recreate lost eras perfectly. The engine itself would be a monument to waste heat. All that thinking makes an immense thermal signature. It might look like a vast, dark sphere in space, covered in intricate fins that radiate heat, a cosmic radiator the size of a solar system, glowing faintly in infrared. From outside, it's silent, cold, and still. But inside, it's a furnace of imagination, dreaming entire cosmoses into being for eons. This creative power mirrors building physical megastructures, but turns inward. It's universe building, not with matter and gravity, but with information and logic. And if a civilization can craft realities inside a machine, it raises a recursive question. How would they know their own reality wasn't made the same way? Building an entire reality, that's the ultimate act of creation, but the canvas is still virtual. The most profound architects, they might choose a more tangible medium, the arrangement of worlds themselves. That's the artificial planetary system. It moves past building one habitat or one ring. A civilization uses the raw material from its star, the star-lifted plasma, to forge planets from scratch. They're not settling for the random, chaotic collection of worlds their star was born with. They're designing a new one, a solar system built to order. It's celestial gardening on the grandest scale. You need a gas giant for its magnetic field to shield the inner worlds. You build one, place it at the precise orbital distance. You want a water world, a shallow global ocean with archipelagos. You assemble it from cometary ice and silicate rock, tune its gravity, its atmosphere. You might even create specialized worlds with no life at all, planets that are just vast, single-purpose factories, their entire surfaces covered in nanoassemblers or quantum processors. Powered by beamed energy from the central star, the orbits themselves become works of art, no more chaotic, gradually shifting paths that lead to instability. The architects place each crafted world into a resonant, perfectly stable orbital dance. Their years might be locked in simple ratios, their gravitational influences carefully balanced to ensure harmony for billions of years. You could even create binary planets, two Earth-sized worlds so close they share a thin, permanent bridge of atmosphere, their citizens able to see the sprawling cities on the neighboring globe hanging immense in their sky. This is a fundamental shift, a civilization's relationship with the cosmos. It's the transition from being tenants who adapt to an environment to becoming the landlords of reality. They're no longer subject to celestial mechanics. They are its masters. They move from finding a home to building the very concept of home, atom by atom. According to their own needs, their aesthetics, the randomness of nature is replaced by the intention of intelligence, its control over matter, gravity, and time. Distilled into the serene, permanent orbits of handmade worlds, and once you can command gravity to arrange planets like marbles, a deeper question emerges. What if you could rewrite the rules of gravity itself? The rules we have for physics, they're not the final ones. They're just the local rules for our part of the cosmos. A civilization that can handle star systems might look deeper into space-time itself and find a flaw, something to use. A cosmic string isn't an object in space. It's a crack, a one-dimensional scar left over from when the universe was born, when everything was unified. They're thought to be thinner than a proton, but with the mass of a mountain range for every inch. A line of pure density stretched across everything. It wouldn't pull matter in, it would cut through it. Its gravity is so strong it bends light, making double images of galaxies behind it. Finding one would be like finding a fossil, a relic from the very first instant. To use it, you wouldn't build a sphere, you'd build a collar, a loop made of something impossibly strong, maybe from space-time fabric placed around a piece of the string. The string has immense tension. It would vibrate, it would thrum like a string plucked at the beginning of time. The harvester's job is to catch that vibration, to absorb those waves of primordial energy and turn it into power. The engineering, it's a confrontation. The forces are near infinite. The densities are beyond anything in a star. One mistake, one flaw in the containment loop, and the energy released could tear a hole in space-time, light years long, but the payoff makes the risk worth it. This isn't a fuel that burns out in billions of years. A cosmic string, if it's stable, could be eternal. Its energy comes from the universe's fundamental geometry. A civilization that builds a string harvester is tapping the capital, the original investment, not the interest. They're plugging their grid into the Big Bang. It's the ultimate deep-time economics, a power supply that could outlast every star. They move from being stewards of their solar system to being accountants of cosmic history, drawing a dividend from the universe's first, most profound imperfection. And if you can find a crack in reality and use it, that leads to another thought. What if you could mend that fabric or weave it into something new, a gateway that lasts forever? That would change reality, the shape of everything. That's what a wormhole stabilizer promises. The wormhole itself, a tunnel through folded spacetime, it's a science fiction idea, but in theory they could be real, microscopic, fleeting, born from quantum foam and gone in an instant. To make one usable, you wouldn't just find it, you'd have to build something around it, a megastructure, a cage of engineering. Its first job is to stop it from pinching shut. And that requires exotic matter, not antimatter, something stranger, matter with negative energy density. It would push the walls apart, hold the throat open against its own desire to collapse. The stabilizer would generate that substance, contain it, weave a lattice of force to keep the gateway stable, but an open tunnel isn't a safe highway. The second function is to fortify the ends. You wouldn't step into a chaotic rift, you'd arrive at a station, a constructed place, a vast armored ring around the shimmering mouth. That's the dock, the customs house, the power plant. It manages the energy, shields travelers from radiation, from gravitational shear, regulates the traffic. It turns a volatile anomaly into a scheduled departure gate. A single gateway would be revolutionary, linking 2 points tens of thousands of light years apart. But the real transformation is a network. Imagine building many of these. Suddenly the galaxy isn't a vast, lonely expanse. Journeys don't take millennia. It becomes a neighborhood, a web of connected points. Distance becomes irrelevant. You could have breakfast in a habitat orbiting one star, and take a meeting in a city inside an asteroid circling another star on the far side of the Milky Way. All in the same day. It creates the first true galactic community. Cultures separated by eons of evolution could meet, trade, blend in real time. The concept of isolation would vanish from their dictionaries. The scale of coordination for that network defies imagination. It implies a central hub, a kind of galactic traffic control, built on a scale that might dwarf a Dyson sphere. A place where the stability of every wormhole is monitored, where transit schedules for 100,000 worlds are maintained, where the exotic matter for 1,000 gateways is synthesized. That hub would be the ultimate monument to unity. It wouldn't just be a building. It would be the physical manifestation of a connected cosmos, a single mind tending the threads that bind separated spacetime into one coherent, traversable whole. It represents the final victory over the universe's most fundamental constraint, the tyranny of distance. And if you can build a network that makes a galaxy small, it compels one more ambition. A paradoxical one. What do you build when everywhere is already within reach? What becomes the ultimate project when travel itself is solved? The center of a galaxy isn't quiet. It's a storm of light and gravity, all swirling around a supermassive black hole. For a civilization that's mastered its own star system, this chaotic heart becomes the final destination. The last frontier isn't the space between galaxies, it's the violent core of their own. That's where they'd build the galactic core hub, and it wouldn't be one structure. It would be an entire engineered ecology, a web of habitats and power stations and computational arrays, all woven into the fabric of the galaxy's center. They'd use the black hole's ferocious gravity as a tool. Its accretion disk, that whirlpool of superheated matter, becomes a power source on an unimaginable scale. It could outshine millions of stars, and you have these dense clusters of ancient suns packed tightly around the core, providing constant, brilliant light. Energy isn't a concern here, it's the medium everything exists in. This hub would be a metropolis on a scale that makes a Dyson swarm look provincial. Think of orbital rings, but not around a planet, around the event horizon itself. Vast, stabilized platforms could float at the edge of the photon sphere, where time slows to a crawl. For beings living there, a single year could see 1,000,000 years pass out in the galactic suburbs. That creates a profound separation. The hub becomes a place for long-term thinking. For governance or computation that needs a perspective spanning cosmic epochs, decisions made in this slow-time citadel could guide the evolution of an entire spiral arm over geological eras. It's the capital city of a galaxy, the ultimate seat of power, not of conquest but of stewardship. All the wormhole traffic, the data streams from stellar networks, the harvest from cosmic strings, every thread of civilization might lead back to this brilliant, engineered heart. And from this vibrant, managed center of everything, the ultimate ambition might then turn outward, to the places where there is nothing at all. To harness the galaxy's core, you have to know what it's really made of. Most of the mass isn't in the stars or the dust, it's in the dark. Dark matter is the silent scaffolding of the universe. It's an invisible ocean the galaxy swims through. It doesn't shine, doesn't reflect, barely touches the world of light. For a civilization that's mastered everything visible, this is the final resource frontier. So how do you build an engine that runs on something you can't see or hold? The answer is a dark matter reactor. It wouldn't look like a sphere or a ring. It would be a ghostly net, a vast, diffuse web of fields and traps spread across light years of what looks like empty space. Its purpose is to gently nudge the dark matter particles that stream through it, to guide them like cosmic shepherds toward a central reaction chamber. There, through means we can scarcely guess, these elusive particles would be coaxed into annihilation. Their mass converted into pure energy. It's the ultimate power source, not from the fire of stars, but from the quiet, fundamental fabric of the cosmos. The visible signature of such a reactor would be subtle. From a distance, it might appear as a faint, persistent glow in a region of void, a soft, unexplained luminescence with no star to cause it. A testament to a physics so advanced it can light a lamp with shadow. This is a profound shift. A civilization is no longer just children of the light, living off the nuclear fires of suns. They've learned to converse with the dark. They've decoded the language of the invisible majority and turned it into a utility. It's the deepest form of understanding. Not just observing nature's rules, but partnering with its most secretive components. And once a culture can illuminate the dark with its own hidden energy, what becomes the purpose of building anything? What do you create when your power is absolute and your understanding is complete? When you've mastered every resource, when every frontier is mapped, you have to ask what's left. Purpose has to be redefined. The ultimate project might not be survival. It might not be power, it could be beauty. A civilization that can move stars might choose to arrange them, to create a stellar sculpture, art on a galactic canvas. It starts with a vision, a shape, a symbol, a story so important it deserves to be written across light years. The medium isn't paint or stone, it's suns and nebulae. The tools are those patient, eon-spanning engines. A Shkadov thruster on a star becomes a brushstroke. Over millions of years, you guide not one star, but dozens. Into a precise formation, you might weave ribbons of reflective dust between them to catch the light just so. You could ignite stars or dim them on a cosmic timetable. Make the sculpture pulse with a slow, majestic rhythm. From a vantage point thousands of light years away, the pattern resolves. It might be a geometric form. Perfect symmetry, a testament to mathematical harmony, or it could be something representational, a stylized life form, a cultural symbol, a memorial shape. The key is scale. This isn't art for a wall. It's art you can only perceive by traveling between solar systems. It exists for the viewer who can step back far enough to see the whole picture. The meaning is twofold. For the creators, it's pure cultural expression. A declaration that their legacy isn't just in what they built to live, but in what they made to feel. For any distant observer who eventually sees it, it's a profound message. It says the builders valued meaning over utility, that after solving all problems of scarcity and energy, they turned their mastery toward creation for its own sake. It transforms the cold equations of astrophysics into a medium for poetry. The night sky, for any species living in its shadow, becomes a gallery. Their constellations aren't accidents of perspective. They're a placed masterpiece, aging over galactic time. And if a culture can sculpt the heavens into a message of peace and beauty, it makes the next possibility all the more chilling. What might they build if peace was not an option? What becomes the ultimate expression not of creation but of protection? A sculpture of stars is peaceful. It assumes a safe universe, but the cosmos isn't gentle, it's violent, random. So a civilization would feel the need to protect, to guard its home, its history. That's the planetary defense grid. It starts with a simple fear, the impact, a rogue asteroid, a fragment from somewhere else coming out of the dark. For a planet-bound people, that's chance. For one with a Dyson swarm, it's engineering. The grid is a system, a nervous system. Its eyes are telescopes. Thousands of them mapping every rock above a certain size. Its hands are the interceptors, orbital platforms with lasers, not to destroy but to nudge. A beam of light focused on one side for years, using photon pressure to push it onto a safer path. It's celestial gardening, patient. For faster threats, the response is kinetic. A projectile, a silent bullet in the vacuum to shatter or deflect. The key is redirection, a gentle hand guiding danger away, but some dangers aren't solid. A nearby star dying, a supernova bathing everything in radiation, or a gamma-ray burst, a beam of pure destruction. For these, the grid evolves. It might deploy a shield. An energy bubble generated by satellites at the Lagrange points. It would shimmer, bend the sunlight, filter out the harmful radiation while letting the light through. From the ground, it might look like a permanent aurora, a guardian halo. A more advanced idea uses smart dust, trillions of microscopic machines, a diffuse cloud around the planet. Normally dormant, invisible, but when sensors detect radiation or micrometeoroids, a signal activates them. They swarm, they link together, forming a temporary barrier exactly where it's needed. A shield that assembles itself, then dissipates. It's living armor. This grid is more than safety. It's the ultimate expression of care. It turns a fragile world into a defended home. The energy and computation to maintain it are a testament, a statement of value. Every life under that shield is worth the effort. It's a parent's instinct made technology. Scaled to a planet, but this shield, this fence around the garden, guards against local dangers, and the universe holds a threat no fence can stop, the end of everything itself. A planetary defense grid is there to protect against threats from a living universe, but the universe itself doesn't last forever. It's winding down. Every star will burn out eventually. Every black hole will evaporate. Everything expands into a cold, dark, uniform sea of near-nothingness. That's the heat death, maximum entropy, the final stillness. And for a civilization that's mastered billions of years, that's not an end you accept. It becomes the final engineering problem. The ultimate project is a heat death engine. It's not a structure for power, but for preservation, a monument to postponing the inevitable. You could think of it as a cosmic hospice, run by the most patient engineers imaginable. Its scale is the entire observable universe, but its operations are achingly slow. A network of near-motionless machines scattered in the void between dying galaxy clusters. Their job is to find the last pockets of usable energy and husband them with infinite care. They might harvest the faint, trillion-year glow from a white dwarf's final embers, or tap the even fainter Hawking radiation from the last primordial black holes, each smaller than a grain of sand. They'd use that vanishing trickle of power not for industry but for maintenance. To keep the lights on in one last tiny pocket of reality, to power one final immense computation, or to sustain a flicker of consciousness, a last mind contemplating the memory of light and warmth in an eternal night. The engineering timescales are beyond comprehension. A single diagnostic cycle for one engine might take 1 billion years, a repair operation 10 billion. Its builders would have to think in units of time where a galaxy's lifespan is just a brief chapter. The structure itself would be almost imperceptible. Not a glittering swarm, but a dark, cold lattice, radiating heat so slowly it blends into the cosmic microwave background, the fading afterglow of the Big Bang. This is engineering not as creation, but as cosmic defiance, a whispered, not yet, into the face of eternity, a project with the ultimate deadline where success is measured not in conquest, but in the sheer duration of a remembered thought. And from that profound, melancholic vision of a civilization facing the end of everything, the perspective shifts back to a simpler, yet equally staggering scale of ambition. A Topopolis is a habitat that doesn't close. It's a tube, a cylinder of living space thousands of miles wide, but it doesn't just circle a star, it spirals. It weaves around its sun, a coil of unbelievable complexity, a single unbroken thread that could be light years long. It's like a ringworld that decided to be a spring instead. A cosmic noodle full of atmosphere, soil, cities, all inside a protective shell. The living space is linear. You could get on a train at one end, travel for centuries, pass through endless environments. One segment might be an engineered wilderness, a 1,000-mile-long forest under an artificial sky. The next could be an ocean section, a contained sea so long the far shore is beyond the horizon, then a metropolitan region, a continuous city stretching for tens of thousands of miles. Each zone is its own world, but connected to the next, a seamless tapestry. The real ambition of a Topopolis is growth. It isn't built all at once. A civilization might start with a simple loop around their star. Then, over millennia, they extend one end. They push the tube outward, building new sections as they go. The structure becomes its own highway, and if they have the patience, the technology, they could aim that growing end toward another star system. Over eons, the Topopolis could bridge the gap, a continuous habitable tunnel connecting two suns. A traveler could go from one solar system to another. Without ever stepping into space, they'd just be on a very, very long train ride through an artificial world that transforms it from a habitat into a literal thread in the fabric of civilization. A megastructure of connection, a physical artery pumping life and culture between distant points. It's a rejection of isolation, choosing to weave star systems together. With a single, unbroken ribbon of engineered reality, a monument to patience, to incremental growth, to the desire to not just visit the cosmos, but to stitch oneself permanently into it. And if a civilization can weave a thread of life between the stars, it raises the final question, the most speculative one. What's the ultimate end goal of that kind of engineering? What could possibly lie beyond even this? To weave between stars, you need a power source beyond stars, so the ultimate power plant, a black hole farm. Not finding one and building around it, making them deliberately, tending to them like crops. At this level, a singularity isn't a pit, it's an engine. A specific kind. Smaller black holes are hotter. They radiate more through Hawking radiation. So the ideal crop is small, managed singularities. The farm would be a containment array of staggering precision. Each black hole may be mountain-sized in mass, held in a magnetic or gravitational bottle, a cage of forces to stop it drifting or merging, and then you feed it a controlled stream of matter, ionized plasma, into the event horizon. That does two things. It sustains the mass against evaporation, and the infalling matter creates an accretion disk, a whirlpool of intense radiation you can also harvest. You're balancing the books, input mass to maintain size, output energy from the disk and the Hawking radiation. The rotational energy, the spin itself, could be tapped. Advanced methods like the Penrose process, drawing power from spacetime. The farm becomes a symphony of controlled fury. Each singularity a contained sun, burning not with nuclear fire, but with gravitational and quantum ferocity. The engineers are like ranchers of ultimate density. Their tools are gravity lenses and magnetic fields the size of solar systems. Their daily work involves calculations where one error could let a black hole evaporate too fast or grow uncontrollably and consume its neighbors. It's the pinnacle, not just using what the universe provides, but cultivating the most extreme objects physics allows. It represents a final intimacy with the laws. You're not just living in the universe, you're curating its most dangerous potentials, and that's the end of the list. 25 cosmic megastructures. From the energy grid of a Dyson swarm to the cultivated singularities of a black hole farm. But the list is just a start. These aren't blueprints, they're thought experiments. Mirrors each reflects a different facet of what a civilization could value. If they seek energy, they build a swarm. Safety, they build a shield. Connection, they build a network. Immortality, they build an archive or a time capsule at the edge of a singularity. Looking at these, the night sky changes. Every quiet star becomes a question. Is it quiet because it's alone or because it's busy? Is the darkness between them empty or threaded with highways and habitats we can't yet see? The greatest mystery isn't whether these things are out there. It's what their existence or their absence tells us about our own future. What do we value enough to build if we are given the stars, and what would that construction say about who we've become? The Fermi paradox comes back around. We've thought about civilizations that build things bigger than planets, that move stars, that use energy from the beginning of the universe. It should be loud out there, but it's quiet, and looking at these megastructures doesn't answer that. It changes the question. The silence might not be empty. It could be full of things we don't know how to see yet. We've been waiting for a beacon, for something obvious, but what if the most advanced work is quiet by design? A Dyson swarm done right would capture almost all of a star's light. To us, that star just disappears. We'd call it a mistake or dust or a weird star. Its real signal, the waste heat, is in the infrared. It's a whisper. We're just now getting telescopes that can listen for that, and that's one idea. Think about a civilization that perfects virtual reality. Once they build their Matrioshka brain, why would they shape stars outside? Their whole world, their art, their travel, could be inside a simulation. Their physical machinery would just be a dark, efficient server. Cool, minimal radiation. To us, it looks like a dead rock. To them, it's everything. Or the cloaking shell, a species that wants privacy, might hide its heat and light signature on purpose. It would just look like empty space, so the great silence could be about where we're standing. We're like kids on a beach looking for sandcastles, while the real builders are working with the bedrock below the water. What they're making is huge, but we can't see it from the shore. That changes how we search. It moves us away from listening for radio signals, which might just be a phase a civilization goes through, and toward being detectives. Looking for cosmic clues, a star whose light doesn't behave right, a galaxy core that's oddly dark, an infrared glow with no star to explain it. These could be the fingerprints. The rough edges of projects so big they fade into the background. The paradox isn't a stop sign, it's a pointer telling us to look closer with better tools and to imagine more. The universe might not be empty, it might be occupied, running on rules we're just starting to see. This journey through cosmic blueprints, it doesn't really give you answers. It gives you a different kind of map. The universe starts to feel less like a wilderness, more like a workshop where the tools are stars. And the projects take eons. We went from the energy grids of Dyson swarms to the quiet engines that could move solar systems across the galaxy. Each structure is a mirror. It reflects a different ambition a civilization might have, the need for power, the longing for connection, the drive to create, or the duty to preserve. The search for intelligence out there, it isn't just about finding neighbors, it's a search for our own potential. These concepts stretch what's possible. A civilization's ultimate signature might not be a message. It might be a monument, not a radio broadcast saying hello, but a shadow moving across a star. Not a beacon of light, but an unexplained warmth in the infrared. Not a star fixed in its path, but one drifting deliberately against the tide of the Milky Way. It changes how you look at the night sky. Every strange flicker, every anomalous glow, they become clues. The great silence feels different now. It might not be silence at all. It might be a language we're only starting to learn, a language written in rearranged starlight, in the geometry of space-time. Our telescopes are becoming translators, learning to read the signatures of engineering on a godlike scale, and that brings it back to us, this vision of cosmic architecture. It's more than a catalogue of far future wonders. It's a challenge, a question for our own species. What do we value enough to build if we are given the stars? Would we weave a network of light to connect? Or turn inward, crafting perfect simulations? Would we become gardeners of suns, or archivists of a fading cosmos, the megastructures we can dream of today? They're sketches of the people we might become tomorrow, so the next time you look up, remember the darkness between the stars. It might not be empty. It could be threaded with highways of light, humming with engines we can't yet perceive. The greatest constructions ever built, they may already be out there, waiting in plain sight for the moment we learn how to see